Google File System, a scalable distributed file system for large distributed data and intensive applications. So scalable distributed systems means user can able to establish the system, how much data going to be delivered or the sharing the other people's. So large distributed data intensive applications, it will be developed by the users or clients. It provides fault tolerance, high aggregate performance to a large number of clients. It is widely deployed within Google's as the storage platform for the generation and processing of data used by the Google service, as well as research and development efforts that require large data sets. The large cluster to date provides hundreds of terabytes of storage across thousands of disks on over the thousand machines, and it's concurrently accessed by hundreds of clients. Early Google effort, big files developed by the Larry Page and Sergey Brin. Files are divided into fixed size chunks of 64 megabytes. Files are divided into fixed size chunks. That size is, the capacity is 64 megabytes. Google file system is not implemented in the kernel of an operating system, but it is instead providing as upper user space library. So Google content management, how they manage in Google file system, the content is going to be managed by the file system. The first one is web information marketing campaigns or social media, personalized for individual users or a group. Google Cloud Platform components and the services to create a content management system that provided by Google Component Platform component. Next one is Google Load Balancer to support traffic routed to multiple zones for the high availability. Google Cloud DNS provides a robust DNS, manages the domain. Static content is a cloud storage. Dynamic content is a cloud SQL implementation. Google Content Management looks like the structure about the Android or iOS using to interact with the Google search engine. The search engine is going to be divided into zone A and zone B. Using that, they can sharing the informations through same. For example, zone A means that will be a auto scaling for accessing the resources from the cloud storage. The dynamic content is going to be accessing the through SQL, by using query we can access the cloud SQL. Then they will publish to the resources of particular output going to be showed by the browser. It will be published on cloud terminal side. So next one is architecture, Hadoop or Google Cloud Platform. Infrastructure for MapReduce using Hadoop, compute power and cloud storage to store the input and output of the MapReduce jobs. Hadoop master includes the HDFS name node and the MapReduce job tracker. Node in the cluster will run MapReduce takes with the data node and MapReduce task tracker, backing up the storage through Google Cloud Storage. Connector for Hadoop HDFS can be used Google's cloud storage. Architecture of Hadoop on cloud storage cloud platform. So client interact with the cloud compute engine. More number of multiple instances having the compute engine. Using that, they can interact with the cloud storage, that is input data. After the again one is output data having the same simultaneously cloud storage. Another cloud storage is available in this structure. Web application on Google App Engine. So that is Hadoop Google Cloud Storage. Here, Google App Engine. Simple development and deployment of web applications with auto scaling, compute power, as well as the integrated features like distributed in memory cache, task queues, and data storage to create a robust applications quickly and easily for application written in Java, Python, PHP, and Go. Supports multiple application versions with support A B testing. Memory cache is in memory cache to provide extremely high speed access to information cached by the web server. So for example, authentication or account information. Task queues provide a mechanism to offload longer running task to backend servers, freeing the front end servers to service new users. Google Load Balancer, which provides a transparent load balancing to applications. Google Cloud DNS is used to manage the DNS domain of users. So this is the architecture of web application on a Google App Engine. So the same architecture of a Google HDFS, the platform is going to be accessed through this architecture. The same way here, iOS or Android, through this terminal, client can access the resources through web application. So it will be Google load balancing. Through this they can access the query through app engine only, the front end of this architecture. Using that front end, we can access static content or dynamic content. Static content having a cloud storage, dynamic content having a cloud SQL and cloud data storage. Using that component, we can access the resources from here. Then task queues are available. Using the task queues, they can schedule the task after the processing going to be happened in app engine. So after complete the app engine, batch app is available in that app engine component. Then app engine, after completing the process, that will be transferred to the cloud SQL or a cloud data storage. Using that, they can provide the output through MAM. So next one is Google Web Toolkit, that is GWT, gives API application programming